At first glance, water seems like something so ordinary and familiar that it holds no mystery. We are born with it, grow up beside it. It follows us every day, filling not only our bodies but most of the landscapes around us. But the moment we ask ourselves, where did it come from on this planet complex, and unclear answers begin to emerge, because water on Earth is one of the oldest and most mysterious substances. It did not simply appear here as a byproduct of planetary formation. Its presence in such quantity is not explained by any classical theory. Scientists still argue about it. Some believe water came to Earth via asteroids and comets that, billions of years ago, carried frozen crystals. But the isotopic composition of water from these cosmic bodies only partially matches Earth's, casting doubt on the theory of a purely cometary origin. Others propose that water formed on Earth itself deep beneath the surface, in the mantle, through chemical reactions between hydrogen and oxygen inside mineral cavities. Indeed, scientists have found evidence that massive volumes of water may exist beneath the Earth's crust, trapped within crystalline structures of rocks. This internal water may still be slowly surfacing and could represent a hidden part of the planet's water balance. But this version, too, has its weaknesses. If water was present from the beginning, then why do other terrestrial planets lack it on such a scale? Why did Earth become a blue pearl in the blackness of space, while Mars remained red, Mercury dry, and Venus a scorching inferno with no trace of liquid? Perhaps Earth fell into a unique window of cosmic events. Or perhaps we are dealing with a phenomenon that lies beyond our usual models. There are theories that suggest water is not just a liquid but an informational substance transferred between planets, between stars, perhaps even across dimensions. Some speculative scientists believe that water may be a carrier of life, a kind of biological matrix that follows the formation of planets, searching for conditions to awaken. And there are even bolder hypotheses that water was brought here intentionally, as part of ancient experiments or by civilizations seeding life. But none of these ideas are proven, so science remains within the bounds of a partial origin model. Part of the water came from space, part from within. But this hybrid concept still doesn't answer the central question: why is there so much of it? If we calculate all the water on the planet, it totals more than 1 billion trillion liters. Oceans, seas, rivers, glaciers, atmosphere, underground springs, lakes, living organisms, even every cloud, all of this is one system. One single substance that never disappears or arises from nothing, only flows from form to form. Water is not just a liquid. It is the memory of the world, its pulse, its legend without beginning or end. And perhaps the answer to where did it come from does not lie in physical models, but in the realization that water is not a part of Earth. It is Earth, and we are merely its reflection. There is no other substance on the planet that interacts with time as deeply as water. It has not merely witnessed change, it has created it. Water is a chronicler, recording history not in words but through erosion, sediment, crystals of ice, and flowing currents. It carved valleys and destroyed mountains, carried minerals across vast distances, and filled voids left behind by ancient volcanoes and tectonic shifts. Water doesn't have memory in the traditional sense, but its presence in geology is its way of remembering. It leaves lines on stone, traces in rock, chemical signatures in glaciers. It's through water that we learn of past climate catastrophes, of great warmings and frozen epochs. By studying ice cores from Antarctica or Greenland, scientists read Earth's past like an archive, where each layer is a page from a million-year chronicle. The ice holds atmospheric gases, dust particles, oxygen, isotopes, all the elements needed to reconstruct portraits of forgotten ages. The history of water is the history of a planet that never stands still. Millions of years ago, ocean levels were different. Where the sea lies today, there were once plains, forests, perhaps even settlements. The sudden melting of glaciers after the last glacial maximum around 12,000 years ago caused sea levels to rise by dozens of meters. Entire regions of land were swallowed by the sea. These are not fantasies, they are facts. Submerged archaeological structures off the coasts of India, Japan, and Cuba are remnants of those worlds erased not by time, but by water. It is no wonder that nearly every culture has a legend of a great flood. Babylon, Sumer, China, India, the Maya, Egypt, even northern peoples all spoke of a time when water covered the earth. In these stories, there is always a warning, always punishment for pride, always hope for rebirth. But why are these legends so similar? Perhaps because they all remember the same thing, an event that truly happened, a global change that redrew the map of the world. Interestingly, according to some reconstructions, before the glaciers melted, sea levels were so low that land corridors existed between continents. People migrated from Asia to America, from Europe to Africa, walking where there is now only water. Water disconnected what was once united. But at the same time, it brought other parts together. It gave rise to new civilizations, forced humanity to search for new shores, to adapt, to build new cultures. Water that drowned the old cities became the foundation of new states, and within this cyclicality, this breathing of the planet melting, flooding, drying, lies a deeper rhythm. Water does not move chaotically. It follows a logic. It responds not only to heat, but perhaps to something more fundamental, maybe to the vibrations of planetary consciousness itself. There is a hypothesis that major changes in Earth's water balance are not only caused by orbital cycles or volcanism, but by events that instruments cannot measure. How can we explain that historical floods often coincide with cultural collapses? Why did great empires Mesopotamia, Mohenjo-Daro, the Maya fall amid either droughts or deluges? Perhaps water responds to the state of civilizations the way a body responds to stress. Perhaps it is not just a substance, but a language through which the earth speaks to us. And if that's true, then water is the mirror of time. It is time's dissolved form. It does not simply flow, it guides us through the pages of a history we have yet to learn how to read. Life, as we know it, cannot exist without water. But this statement has been repeated so often that it's lost its weight. We take it as a cliché, without truly considering how deep and mysterious this truth is. Water is not just a medium for life, it is its matrix, not a passive backdrop, but an active participant in biochemistry. Every cell is a watery microcosm. Every thought, movement, memory, electrical, chemical impulses moving through liquid channels. Inside each of us is an ocean that has learned to think. Water is the foundation of metabolism. It carries nutrients, removes toxins, regulates temperature. But beyond biology, water is even more intriguing. Its molecules possess a unique ability to form hydrogen bonds, which create flexibility, adaptability, and informational potential. These properties make water not just a condition for life, but also a carrier of it. Its structure allows it to store information, shift, influence the organization of DNA molecules. We tend to see life as a result of chemistry, but perhaps life is a manifestation of water that has learned to be complex. Ancient hypotheses about the origin of life speak of a primordial ocean, a warm, watery cradle, where, under the influence of lightning and volcanic energy, the first organic compounds emerged. But what exactly made this breakthrough possible? Maybe not just the chemical ingredients, but water's behavior itself, its ability to shape structures, interact with proteins, bring them together into something new. In this sense, water is not merely a condition, it is a co-creator. Going deeper, we find something fascinating. All living beings from bacteria to humans contain almost the same percentage of water, around 70%. Just like Earth's surface, this is not a coincidence. It may be a clue. Water is a universal blueprint on which life is based. It is everywhere, in everything, and the same from the simplest organism to the complex human brain. It is the one component that carries life through all its forms. Equally intriguing is how water behaves in extreme conditions. It retains its properties even in very low temperatures, remains liquid within a narrow range, but within that range does incredibly much. In climates where life seems impossible, water saves the system dew, mist, underground springs. In deserts, water is the only condition for life. And where it appears, everything revives instantly. It's like memory awakening. Water remembers what life looks like. It activates seeds, microorganisms, ecosystems. It doesn't just moisten, it awakens. Even more profound is how water connects all organisms into one ecosystem. The water cycle is not just the movement of droplets between sky and soil, it is the movement of life. The water that once flowed through a dinosaur may now be in your kettle. It moves from plants to animals, from oceans to clouds, from people to rivers. It never disappears, it only changes form, space, purpose. And in this eternity lies its magic. There is another dimension, psychophysiological. Human consciousness reacts to water not only physically, but emotionally. Near the sea, we feel calm. At a spring, we feel hope. The sound of rain can evoke nostalgia. These are not mere associations. They reflect a deep connection between our nervous system and the environment it arose in. We are water beings not just physiologically, but psychologically. And so, when we destroy water, we destroy ourselves. Because every drop is not just a resource, it is a fragment of the planet's living memory. Water has no form. It takes on form, but never possesses its own. And in this lies its strength. It moves according to the landscape, but simultaneously shapes it. It flows under the laws of gravity, but transforms the planet's surface and climate. Water is motion not chaotic, but purposeful, global, interconnected. Its currents flow through Earth underground, on the surface, in the atmosphere. We often think of water locally, a river, a lake, a rain, a well. But in truth, it functions as a single system. The oceans aren't just large bodies of water, they are massive heat engines transporting energy from the equator to the poles. The Gulf Stream isn't just a warm current. It's a river within the ocean that affects the climate of Europe, Africa, the Americas. If it stops, the entire northern hemisphere would change. And there are hundreds of such currents. They form underwater highways that nourish the planet, carrying not just warmth, but salts, nutrients, organic matter. Atmospheric water is even more complex. It evaporates in one place, is carried by winds for thousands of kilometers, and falls as rain somewhere else. The Amazon, for example, is not primarily fed by surface sources, but by atmospheric moisture that arrives from the Sahara Desert. Yes, Saharan dust, carried across the Atlantic, fertilizes clouds over South America. This is a breathtakingly global web of connections. We see a cloud and think it just appeared. But its origin is a story of interaction between oceans, land, wind, temperature, and time. Rivers, too, are more than streams. They are the veins of the planet. They carry more than water. They link ecosystems, nations, histories. The Dnipro, the Amazon, the Ganges, they are not just geographic features. They are structures that unite thousands of springs, rains, snowfalls, glaciers into a single flow. And that flow is alive. It responds to climate, deforestation, pollution, human greed. Underground, there is another system. Subterranean rivers, lakes, aquifers, hidden reservoirs that slowly but steadily shape the fate of regions. In some places, water flows underground for millennia and only rarely emerges. In others, it's locked in stone, but under pressure it seeps through, changing the chemical structure of rock, forming caves, minerals, geothermal networks. Water is everywhere. And it moves constantly. It goes from ocean to atmosphere, from atmosphere to snow, from snow to river, from river to sea. But it is never lost. It's always moving, exchanging, transforming. And this motion is the planet's lifeblood. Without water, Earth would be a dead sphere, not just lifeless, motionless, without seasons, without winds, without change, without evolution. Water is the engine behind everything else, but its motion isn't just physical. Water is a symbol of connection. It erases borders. It unites mountains and oceans, deserts and jungles. It is the network through which the planet talks to itself. A new scientific concept is emerging: the global water internet. The idea that water is an informational medium, storing and transmitting signals between regions. For example, glacier melt in Greenland can influence ocean currents near Australia. It's like the planet's nervous system, and we are only beginning to understand it. Everything we do to water here echoes over there. This is the spatial principle of unity. Water doesn't recognize political borders. It recognizes only gravity, temperature, and time. And in that lies its truth and its warning. Imagine that water has memory, that every drop remembers where it has been, what it has passed through, what it has touched. It sounds like poetry or science fiction. But more and more researchers are posing this not as a metaphor, but as a hypothesis, because water behaves differently than any other substance. It reacts, it remembers. It changes not only under temperature or pressure, but, it seems, under the influence of information. In the 1980s, French immunologist Jacques Benveniste conducted a series of experiments that caused a storm in the scientific world. He claimed that water could retain the imprint of substances, even when they were diluted to the point that no molecules of the original remained. His results were often criticized and questioned, but the idea persisted. Later, Japanese researcher Masaru Emoto became famous for his photographs of ice crystals. He froze water that had previously been exposed to different words, music, prayers, emotions, and he claimed, water reacts. Crystals of water that heard words like love or thank you were harmonious, symmetrical, beautiful. Those that heard hate or I will kill you were chaotic and distorted. Many dismissed this as pseudoscience. But others began to wonder, why does water, seemingly so simple, behave so complexly? Modern physics introduces the hypothesis that water's structure is not a random collection of molecules, but a complex, dynamic lattice that changes depending on external influence. Water can be rewritten like a flash drive. It can store signals, frequencies, vibrations, and perhaps that is why it can carry memory, not only physical, but maybe emotional or energetic. Some scientists talk about water's cluster structure, how molecules group into stable formations that respond to external information. For example, water that flows through pipes loses its natural structure, while spring water retains a primordial harmony. But how can this be measured? How can it be proven? How do we avoid slipping into mysticism? Perhaps we simply don't yet have the tools to fully understand, just as we once couldn't see bacteria or waves until we invented microscopes and radar. At the same time, in cultures around the world for millennia, water has been regarded as sacred. Holy water in temples, springs visited for prayer, cleansing rituals, washing rites. In all traditions, water is not just a substance, it is a bearer of meaning. We touch it to purify, we drink it to renew. It is a symbol of life and of transition. When a person dies, their body is washed. When a person is born, they are bathed. This is no coincidence. We feel water remembers something. It carries something, transmits something. And then there is one more, even stranger hypothesis, that water can transmit not only information, but intention, that our thoughts, emotions, and mindset influence it. And that you can even feel it in a simple glass if you thank it before drinking. This is not proven. But who said truth must always be proven in a laboratory? Sometimes truth echoes in the heart. And water may be its mirror. What if we looked at the history of humanity not through the lens of war, gold, or empires, but through the lens of water? What if we searched not for pyramids, but for ancient canals, reservoirs, and underground springs? The picture would change. Much of what we call desert was once green. Many of the places we call ruins are remnants of water technology. The world's oldest civilizations were born by rivers. That's no coincidence. The Sumerians, Tigris and Euphrates. The Egyptians, Nile. The Indus Valley, Indus. The Chinese Yellow River. All of them didn't just use water, they controlled it. Canals, locks, drainage systems, reservoirs, all of these were built thousands of years ago. In India, there are Baoli's deep stepwells carved into the earth. Some are over 2,000 years old. They didn't just store water, they served as temples, gathering places, community centers. In South America, researchers still study the mysterious hydraulic structures left by the Incas. For example, the terrace and canal system in Moray, which allowed control over microclimates, humidity, and even air temperature. But the most mysterious are those structures we cannot explain. In Bosnia, tunnels where water flows against gravity. In Turkey, underground cities with ventilation shafts and water drainage systems that still function. In Peru, the Nazca lines that point to underground aquifers. All of this gives the sense that water was once more than a resource. It was a source of knowledge. Some researchers suggest we are not the first technological civilization on this planet. That there were others before us. And if that's true, water may have preserved the traces, because it is the least altered. It flows, but it does not forget. Strangely, some ancient canals were laid out with such precision, it's hard to match even with modern instruments. In Iran, Connaught's underground water channels over 2,000 years old still work. They use the land's gradient so precisely that water flows unaided for dozens of kilometers. In Andalusia, aqueducts built during the Moorish era still function, and this is only what remains. How much more lies buried under earth, under sand, under sea? Atlantis may be a myth, but perhaps not entirely fiction. If a civilization once used water as energy, as information, as communication, its legacy wouldn't be in palaces, but in flows, reservoirs, and wells. Perhaps we don't recognize it because we're not looking in the right direction. And even stranger, all these structures share something in common. Harmony with the landscape, integration with nature, not destruction, but collaboration. As if their builders didn't just construct, they listened to the land, heard the water, and negotiated with it. And we've forgotten that art. We've forgotten the history of water. But water has not forgotten us. Water is not just a substance that makes up most of our bodies. It is a bridge between the external world and our inner world. It has long been observed that water reacts to emotions, thoughts, and even intentions. Researchers from various countries have conducted experiments where people focused on water, spoke words of gratitude or love to it, or conversely, anger and fear. The results were surprising. The structure of water changed depending on the emotional load. But how is this possible? Science does not yet have a definitive answer, but new horizons are opening in quantum physics and information theory. Consciousness may not be only a product of the brain, but a phenomenon that interacts with matter more subtly than we imagine. Water, which is the main component of our bodies and the planet, may serve as a conductor of these interactions. Psychologists and shamans, doctors and biologists all find a special resonance in water. In traditional cultures, water is a living entity that feels and responds. In modern medical research, water in the body can change its state under the influence of thoughts and stresses, reflecting on a person's health. Collective consciousness is another realm where water may play the role of an information carrier. We remember how water participates in climate cycles, transferring energy from one part of the planet to another. Perhaps, on a subtle level, water stores and transmits information that reflects not only physical, but also psychological and spiritual processes of humanity. Perhaps that is why we instinctively seek to be near water rivers, lakes, seas. There we feel calm, renewal, harmony. And this is not a coincidence, but a resonance with our inner water, the water flowing inside us and connected to all life on Earth. Consciousness and water, two elements intertwined, nurturing and changing each other. and perhaps in their interaction lies the key to understanding life, health, and harmony. Water is not only the foundation of life, but also the key to humanity's future. The modern world faces challenges: climate change, pollution, increasing consumption. Yet science and technology offer solutions that can change our relationship with water. One of the most promising areas is water purification and reuse. Modern filters, membranes, and biofilters can remove even the tiniest pollutants, microplastics, viruses, and bacteria. Some researchers are developing systems that can desalinate seawater more efficiently and cheaply than before. Water is a source of energy. Hydropower has long been used, but now many hydroelectric plants, pumped storage systems, technologies harnessing waves, tides, and even underwater currents are developing. Innovations in water energy can provide clean, renewable energy accessible even in remote areas. Moreover, water is the basis of future biotechnology and medicine. Water is the medium for cellular processes, drug delivery, and the creation of biomaterials. Water in nanotechnology and synthetic biology becomes a material for new discoveries. Preserving aquatic ecosystems is another key direction. Rivers, lakes, seas are not just water sources but parts of a global balance. Restoring wetlands, protecting coral reefs, and fighting erosion help maintain climate stability and biodiversity. Social projects increasingly focus on providing clean drinking water to remote villages and developing water-saving technologies in agriculture. The future of water is a synergy of tradition and innovation, nature and technology, science and the wisdom of generations. Water teaches us to value time, conserve resources, and look forward with hope. It is an inexhaustible source of life and change that can lead humanity to harmony with the planet. And how we treat water today determines our shared tomorrow. Water has long been a source of inspiration for humanity. In the myths and legends of various cultures, it often appears as a sacred element, a symbol of purification, rebirth, wisdom, and immortality. In ancient mythology, water is the boundary between the world of the living and the world of the dead, the river Styx that carries souls to the other world. In Christianity, water symbolizes the cleansing of sins through baptism, the beginning of new life. In Hinduism, the Ganges is a sacred river where everyone can cleanse their soul and receive blessings. Ancient Slavs considered water a living entity with its own spirit, and many peoples have rituals linking water to fertility and protection. In modern culture, water remains a symbol of profound change, transformation, and the flow of life. It is immortalized in art, poetry, films, and music. This symbolism reminds us of humanity's connection with nature, the cyclicality of life, and the power that lives in simple yet extraordinary things. Water is the planet's memory, preserving traces of the past and opening a path to the future. It is a silent witness to humanity's stories, a bridge between generations and cultures. When we look at water, we see not just a physical substance, but a whole mosaic of meanings and senses shaping our perception of the world. Water is one of the most important components of Earth's climate system, its main regulator and driving force. It circulates in nature in a continuous cycle, transforming from liquid to vapor, ice, snow, and back to liquid, nourishing all life and shaping the climatic conditions essential for the existence of our planet as we know it. This water cycle is one of the most complex and harmonious systems, linking oceans, atmosphere, land, and living organisms. Over 97% of all water on Earth is concentrated in oceans and seas, which serve as the true heat engines of our climate machine. Water has a unique ability to store and transfer heat, determining the temperature and weather of regions worldwide. Ocean currents such as the Gulf Stream and the Labrador Current are like highways of heat, moving warm water from the tropics to northern latitudes. These currents shape the climate of countries, causing milder winters or harsher cold seasons. Without them, northern Europe would be much colder, and the coasts of North America would experience different climatic influences. At the same time, oceans absorb huge amounts of carbon dioxide, regulating greenhouse gas concentrations in the atmosphere and impacting global warming. Earth's atmosphere contains about 12,900 cubic kilometers of water vapor that is constantly moving and changing, forming clouds, precipitation, and evaporation. Clouds play a dual role. They reflect some sunlight back into space, cooling the surface, and trap Earth's thermal radiation, creating a greenhouse effect. This interaction determines the climatic balance and directly affects weather. Changes in water vapor concentration can cause both extreme droughts and heavy rains and floods. Due to climate change, we witness increasing intensity and frequency of natural disasters such as hurricanes, typhoons, floods, and prolonged droughts. Melting glaciers and polar ice caps caused by rising average temperatures lead to sea level rise. This threatens coastal cities, low-lying countries, and islands, causing displacement of populations, loss of land, and infrastructure destruction. Furthermore, changes in water temperature and ocean chemistry affect marine life, disrupting the ecological balance and impacting global food security. Water in ecosystems acts as a key factor of biodiversity. The amount of precipitation and soil moisture determine the diversity of flora and fauna, directly influencing the stability of natural systems and their ability to adapt to changes. Wet forests, wetlands, river systems all are vital links in the climate system, interacting with the atmosphere and oceans. Modern scientific research actively studies the interconnections of water and climate to forecast future changes and develop effective adaptation strategies. Climate modeling allows predictions of warming consequences, shifts in precipitation zones and winds, which is crucial for agriculture, energy, urbanization, and nature conservation. Thus, water is the heart of Earth's climate system. Its circulation defines weather, supports life, and forms the planet's ecological balance. Understanding this interaction helps humanity not only conserve natural resources but also adapt to new climatic realities, ensuring a sustainable future for coming generations. Water is not just a natural resource, but a deep symbol and an inseparable part of human culture and art. Since ancient times, it has embodied life, purity, renewal, and transformation, captivating human imagination and inspiring the creation of diverse artistic works reflecting its significance for humanity. In ancient civilizations, water was often considered a divine gift. The Egyptians worshipped the Nile, which not only nourished the land but was a symbol of divine wisdom and immortality. Cities and sacred structures were built around rivers and water bodies, and water became a source of myths, legends, and religious rites. Water in sacred architecture was used not only as a practical element, but also as a symbol of purification and transition to other worlds. In China, water acquired special philosophical meaning. Confucianism and Taoism viewed it as a symbol of flexibility, patience, softness, overcoming hardness. These ideas were reflected in calligraphy, painting, and poetry, where water became a metaphor for life's flow, continuity, and change. In Chinese culture, water is not only an element, but a way of understanding the world and oneself. In European art, water had multifaceted meanings. In the Middle Ages, it symbolized the cleansing of the soul and Christian baptism. During the Renaissance, harmony and beauty of nature. In the Baroque, drama and emotion. Water in painting became a stage for myths, biblical stories, romantic landscapes, and storms reflecting deep human feelings. In poetry and literature, water often represented change, life and death, and inner transformation. In modern art, water gained new meanings. It became material for installations, video art, and performances. Artists explore human nature interactions, ecological changes, and the impact of technology on the environment through the image of water. Water is used as a metaphor for the flow of time, life's impermanence, and emotional and spiritual states. Video art and sound recordings imitating water noises create an atmosphere of immersion and meditation. Music inspired by water uses rhythms of waves, raindrops, and streams to create a special sound palette that evokes emotions and associations with nature. In literature, water symbolizes freedom, change, and the depths of the subconscious. Novels, poetry, and philosophical treatises often refer to water as a source of life and wisdom. Thus, water connects nature and culture, the physical and spiritual, the past and the present. It remains a living and powerful symbol inspiring humanity and reminding us of our inseparable connection with nature. Understanding water's significance in art and culture helps deepen appreciation of this resource and the responsibility to preserve it. Water is a unique and indispensable component of life on Earth. It covers the entire planet, enveloping it with oceans, filling rivers, lakes, and glaciers, and penetrating deep beneath the ground. Although we often imagine water as something visible and easily accessible, the largest volumes of it are hidden from sight in underground reservoirs and in the depths of ocean basins. These hidden worlds are incredibly important for sustaining life, regulating climate, and maintaining ecological balance, yet they remain some of the least studied and most mysterious systems on our planet. Groundwater forms vast reserves that feed rivers, maintain soil moisture, and serve as a source of fresh water for billions of people worldwide. It is stored in soil pores, cracks, and caves, sometimes lying hundreds or even thousands of meters deep. Groundwater can be shallow or deep. Shallow, or soil waters, quickly respond to precipitation and climate conditions and are directly connected to surface water bodies. Deep groundwater may exist under great pressure in porous rocks or fractures, sometimes isolated from the surface for thousands or even millions of years. They can contain unique information about ancient climatic conditions and geochemical processes that occurred on the planet. Studying groundwater not only helps locate new sources of fresh water, but also reconstructs climate history. The isotopic composition of water in various layers reveals how temperatures and precipitation patterns have changed over Earth's distant past. This is crucial because understanding climate fluctuations helps predict future changes. Groundwater also influences ecosystems by sustaining river and lake flows during droughts, supporting plant and animal life. A unique aspect of groundwater is that it harbors special organisms extremophiles that have adapted to live without light, under high pressure, and in chemically harsh environments. They use chemosynthesis, a process of obtaining energy from chemical reactions rather than sunlight. Discovering such life forms is significant not only for biology but also for astrobiology, as it shows that life can exist in extremely hostile conditions similar to those that might be found on other planets and moons. The deep oceans are an even more mysterious world. Ocean depths reach over 10,000 meters in the deepest trenches, such as the Mariana Trench. There, immense pressure, near-freezing temperatures, and total darkness prevail. Life seems impossible in such conditions, yet numerous studies have shown that ocean depths are inhabited by a diverse array of organisms, from microscopic bacteria to deep-sea fish and invertebrates. Especially unique are ecosystems associated with hydrothermal vents, so-called black smokers. Discovered in the 1970s, these vents emit hot water rich in minerals and chemical compounds that serve as energy sources for extreme life forms. Organisms living in these ecosystems survive without sunlight and use chemosynthesis to produce energy. These discoveries have greatly expanded our understanding of the limits of life and have propelled new research in biology, ecology, and potential energy sources. Groundwater and deep oceans also have enormous significance for the global climate. Groundwater affects the level and quality of water resources, which in turn support flora and fauna, while the oceans are the planet's largest reservoirs of heat and carbon dioxide. Ocean currents, which determine the climate in various regions, depend on the temperature and salinity of water, which vary at depth. Changes in these parameters in the deep ocean can trigger significant fluctuations in climate systems, leading to hurricanes, droughts, or floods. Research of these hidden worlds is greatly complicated by the conditions they exist in. High pressure, absence of light, and difficult accessibility require specialized technologies. Modern research methods include remote sensing, robotic underwater vehicles, autonomous unmanned submarines capable of exploring ocean depths, and deep drilling to obtain groundwater samples. Thanks to advances in molecular biology and isotopic analysis methods, scientists can obtain detailed information about the chemical composition of water, detect microorganisms and their biological activity, and trace geochemical processes occurring in these complex environments. This opens new opportunities for understanding the role of water in ecosystems, geological processes, and for predicting the consequences of climate change. Preserving groundwater and deep oceans is critically important for sustainable development. Pollution, excessive water extraction, climate change, and technological impacts threaten these water systems. Loss or degradation of groundwater quality can lead to depletion of freshwater reserves, reduced soil fertility, and deterioration of rivers and lakes. Changes in oceans can cause intensified climate disasters, loss of marine ecosystems, and deteriorated livelihoods for millions depending on ocean resources. Thus, deep oceans and groundwater are not only vast water reserves, but also unique habitats, keys to understanding the past, present, and future of our planet. Research of these worlds continues to expand our knowledge, and technological progress opens new horizons for science and practice. Conservation and responsible use of these resources are among the most important tasks of our time to ensure life on Earth and its sustainable development. Water is one of the most essential substances for life as we know it. It is not only the foundation of most biological processes, but also plays a key role in shaping and maintaining the climate and geological systems on planet Earth. Therefore, when it comes to the search for life beyond our planet, water occupies a central place in scientific research and ideas about possible habitats. The idea that water exists beyond Earth and could be the key to discovering extraterrestrial life is transforming our understanding of the universe and our place in it. Earth is a watery planet, with about 71% of its surface covered by oceans that have created favorable conditions for the development of complex life forms. However, the discovery of water in various forms on other celestial bodies expands the horizons of research. Water in space exists not only as ice but also as vapor, in liquid form beneath the surface, and in chemical compounds that can support biochemical reactions. This opens new perspectives for understanding the potential for life beyond Earth. One of the first and most promising objects in the search for cosmic water is Mars. For many years, Mars was considered a dry and dead planet, but modern missions such as the Curiosity and Perseverance rovers, along with orbital satellites, have confirmed the presence of water ice in the polar caps and traces of salty liquid water in the past. The discovery of Martian river valleys, channels, and minerals formed in the presence of water indicates that the planet once had conditions favorable for life. Although today Mars's surface is cold and dry, underground water reservoirs may exist and sustain potential microbial life. Other bodies in the solar system also attract scientific interest. Europa, a moon of Jupiter, is covered by a thick ice shell beneath which, according to spacecraft data, lies a vast ocean of liquid water. It is considered one of the most promising places to search for extraterrestrial life due to the presence of water, chemical elements, and energy necessary for biological processes. Similar conditions are likely on Saturn's moons, Enceladus and Titan. Enceladus ejects plumes of water vapor and ice particles into space, indicating active geological processes and the presence of liquid water beneath the surface. Titan has a dense atmosphere and lakes of methane and ethane liquids that could serve as water analogs in alien environments. Water in space is not limited to the solar system. Observations of interstellar clouds of gas and dust have shown that water in the form of ice and vapor is a widespread phenomenon. Water molecules have been found in comet atmospheres, which are cosmic time capsules, preserving information about the primordial conditions of planet formation. There is a hypothesis that comets delivered significant amounts of water to early Earth, contributing to the formation of oceans and life. Studying cosmic water is connected to profound scientific questions about the origin of life and the conditions necessary for its existence. Water is a solvent in which key biochemical reactions take place. Its unique physical and chemical properties, such as high heat capacity, the ability to form hydrogen bonds, and a wide range of liquid state, create a favorable environment for complex organic molecules. This makes water indispensable for all known life forms and guides the search for extraterrestrial life in space. However, ideas about water and life beyond Earth are expanding. Scientists are considering the possibility of alternative solvents, such as ammonia or methane, that might support chemical processes under extreme conditions on other planets and moons. This allows for imagining that life may not necessarily be Earth-like, and that water, while the most probable candidate's not the only possibility. Research on cosmic water stimulates the development of new technologies and missions. Modern space probes are equipped with instruments to detect water in various forms, analyze its composition, and search for biomarkers. For example, NASA's Europa Clipper mission is preparing to explore the ocean beneath Europa's ice, and planned missions to Enceladus and other moons aim to find signs of life. Water in space is not only the key to understanding the origin and distribution of life, but also a potential resource for future space travel and colonization. Water can serve as fuel, a resource for producing oxygen, and life support on space stations and extraterrestrial bases. Therefore, studying it has not only scientific but also practical significance for advancing space technology and humanity's presence beyond Earth. Thus, cosmic water opens a new frontier in the study of the universe. It expands our understanding of life, its possibilities and limits, posing new questions and challenges. Future discoveries may fundamentally change our view of our place in space and where and how life might exist beyond Earth. Water is our most precious resource, yet it is under threat. Pollution, climate change, population growth, overuse all place water at the center of global challenges. However, humanity has all the tools to change the situation. Innovation, international cooperation, and conscious resource management will help preserve water for future generations. Water is not just a substance. It is life, culture, history, and the future. Each of us can contribute, starting with conservation, supporting ecological projects, education, and spreading awareness. Only through joint efforts can we achieve harmony between humans and nature. Water is a symbol of our shared responsibility and hope. It teaches patience, change, and the continuity of life. The planet's future depends on how we treat water today. Let this element be not only a source but a guiding light in a world ruled by wisdom and care. Thank you for watching until the end. If you enjoyed this video, give it a like. It really helps the channel grow. And don't forget to subscribe so you won't miss future videos about the mysteries of our planet.